Okay, today we're going to look at Lesson 2, and your learning objective or I can statement is I can factor by grouping. So Lesson 0 was a review of some combining like terms and the distributive property. Lesson 1 was factoring out the GCF. And so now we're moving on to factoring by grouping, which requires you to factor out the GCF. So we're going to be doing some more practice, finding the GCF of some terms in an expression. And we're going to use that to factor by grouping. So just a reminder, as I teach in the video, I'm going to be going faster than I would if we were in person. So remember, you can pause and rewind and whatever you need to do to match your own pace. And if you have questions or you have trouble or it's not making sense, you can always jump back in the Google Meet after you watch the video and let me help you. Okay, so you should have a notebook, something to write with. Write down these notes, go with me, try the examples, and then you'll be ready to do your homework assignment in Math Excel. First, we're going to start with some steps. So this is just the order that you can go in to solve these problems, or to factor these problems. After you do a couple, you might not even need to refer to the steps, but you'll always have them just in case you need them if you write them down. So the first thing we need to do is to make sure the polynomial is in order. So that means our exponents are going from biggest to smallest. Okay, so you might have an exponent of 4, 3, 2, 1, and then just a constant. Okay, so it does need to be in order. Then the first thing that you're going to do after that is check for a GCF of the whole expression. So look at every term and decide if there's a greatest common factor that you can pull out. Step number 2, you're going to split the expression in half. Your expression will probably have 4 terms, so you can just split it down the middle. And this is where we're going to go back to what we did yesterday. So you're going to look at the first half of the polynomial and pull out the GCF. So you'll have the GCF and then your leftovers in parentheses. And then you'll do the same thing to the second half. And what you have in the parentheses should match. Then you're going to look at what you have left, pull out the common factor, and then put what's left in parentheses. So your answer, if you have a greatest common factor in step 1, you'll have that out front, and then you'll have 2 factors in parentheses. And you can always check your answer with the distributive property. So we're going to work through some examples, and I'm going to talk you through these steps. The first problem that we do, I'm actually going to number the steps in the problem so you can see what's what. Okay, here's example number 1. We have 30x to the 4th minus 25x to the 3rd plus 60x squared minus 50x. So if you look, this is in the correct order because our exponents are going from greater to smaller. And now we need to look and see if there's a GCF. So first you should see that there's an x in every term. So there is going to be a GCF. We're definitely going to be able to pull out an x, but what else? We've got 30, 25, 60, and 50. What's a number that can go into all of those evenly? 5. Can anything larger than 5 go into each of them? No. So 5x is going to be your GCF. So that matches step number 1 that we did before. Okay, so step number 1, we have 5x, and we need to put our leftovers in parentheses. So 30 divided by 5 is 6. If you have 4 x's, you take out 1. There's 3. Negative 25 divided by 5 is negative 5. You have 3 x's and take out 1, so there's 2 left. 60 divided by 5 is 12. You have x squared, take out an x, there's an x left. Negative 50 divided by 5 is negative 10, and there was 1 x, and we took it out. Okay, so that's step number 1. Step number 2, split the expression in half. So I'm just going to draw a line right down the middle of what's in parentheses. So that's step number 2. So we've got step number 1 was the GCF. Step number 2 is split it in half. Okay, so let's look at this first half. So step number 3, factor the GCF out of the first half. So 5 and 6, 1's the only thing I can pull out there. We have x cubed and x squared, so I can take out an x squared. And so 6 divided by 1 is 6. I have 3 x's, and I take out 2, so 1 is left. Negative 5 divided by 1 is negative 5. and I had x squared. I took out x squared. There are no x's left. Okay. Step number 4, we're going to do the same thing, but on the other side. So 12 and 10. The largest number that goes into both of those is 2. Only one of them has an x, so we can't take one out. 12x divided by 2 is 6x. Negative 10 divided by 2 is negative 5. It should be a positive. I forgot to add it there. Okay, and we made a little note up here that what's in parentheses should match. Do they? Yes, so we're in good shape. So now is step number 5. We're going to look at what we have, pull out the common factor, and then put what's left in parentheses. Okay, so if you look at these two terms, that's just like having x squared y plus 2y. If you look at this, you can tell me that they have a y in common, and so I put the y in front, and I'm left with x squared plus 2. The same is true here, except instead of y, we have the quantity 6x minus 5. So I'm going to bring that down, 6x minus 5. I'm going to put the new leftovers in parentheses, so that's x squared plus 2. I'm going to bring down my GCF from earlier, and this is my final answer. So I could do the distributive property with this 5x, and then I could do the double distributive property, and it should take us to what we started with. Okay, but that is our final answer. And you're going to follow that same pattern every single time. Okay, here's example number 2. We have 30r cubed minus 6r squared minus 50r plus 10. So each term doesn't have an r, but we have 30, 6, 50, and 10. All of those are even, so what number can I pull out of all of the even numbers? A 2. So that leaves me with 30 divided by 2 is 15, and we didn't bother the r's, so they'll stay the same. Negative 6 divided by 2 is negative 3. Negative 50 divided by 2 is negative 25. Again, the r's are staying the same, and 10 divided by 2 is 5. Okay, so now we can move on to step number 2. We're going to split what's in parentheses in half. Okay, and we're going to factor out the GCF. So on the first side, we have 15 and 3. So we can pull out a 3, and then we can pull out r squared. So 15 divided by 3 is 5, and we have 1 r left. Negative 3 divided by 3 is negative 1, and we took out all the r's. Okay, on the second half, this first number is negative, so that means that we have to pull out a negative. If nothing else, we would have to pull out a negative 1. But we do have a GCF here, 5 and 25. What's the largest number that goes into both of those? 5. So negative 25 divided by negative 5 is 5, and we leave the r. 5 divided by negative 5 is negative 1. And we made a note that what's in parentheses should match, and it does. So you're going to pull out that common factor, so that 5r minus 1. Put your leftovers in parentheses. Right? Bring down your GCF from the beginning. And there is your final answer. And I just realized that I meant to do all that work in pink, but it's okay. Hopefully you can follow along just fine. Okay, looking at example number 3, we have 25n cubed plus 15n squared minus 15n minus 9. So just looking at this, I see the 25 and 15s, and that makes me think that there's a GCF of 5. But can 5 go into 9 evenly? No. Okay, so, and each term doesn't have an n, so we don't have a GCF here, so we're going to go straight to step number 2, where we split the polynomial in half. So now, 25 and 15, the GCF is 5. You have n cubed and n squared, so we can pull out n squared. 25 divided by 5 is 5. If you have 3 n's, take out 2, you're left with 1. 15 divided by 5 is 3, and you had n squared, and we took it out. So it's just 5n plus 3. Okay, on this other side, again, our first number is negative, so that means we have to pull out a negative. All right, what's the GCF of 15 and 9? The largest number that goes into both of those is 3. So negative 15 divided by 3 is 5. And we bring down the n. Negative 9 divided by negative 3 is positive 3. And you should see the stuff in parentheses matches, so we're good to go. We're going to pull that common factor down in front, that 5n plus 3, and put our leftovers in parentheses. So 5n squared minus 3. And there's your final answer. So hopefully you've noticed we're following the exact same steps every single time, same process. And if you look at your answers, like your GCFs, you should see a pattern. So after you pull out the GCF out of everything, the first GCF you get is squared. Your second one is just a constant. In the final common factor, there's no exponents. Okay, so you should see a pattern that might make it a little bit easier for you. Okay, here are examples 4 and 5. I want you to write these down, give them a try on your own, pause the video, and then check your answers with me. Okay, so number 4, we don't have a GCF because we have 1, 7, 5, and 35. So none of those are, the only thing that we can pull out of there is a 1, and we don't have to do that. They don't each have an x, so we can skip straight to splitting it in half. And we need the GCF of the first half, and that's going to be x squared. If you have x cubed and take out 2, you're left with x. And then the other one, we have a negative 7, and we just took off that x squared. 5x minus 35, our GCF is positive 5. 5x divided by 5 is x. Negative 35 divided by 5 is negative 7. Our new common factor is x minus 7. We put our leftovers in parentheses, so x squared plus 5. Okay, number 5 is similar. We don't have a GCF, so we can start by splitting it down the middle. Our first side, we can pull out an x, and we're left with x plus 2. The other side, we start with a negative, so we pull out a negative, and we can pull out a negative 2. So we're left with x plus 2. Our common factor is now x plus 2. And in parentheses, we can put our leftovers, x minus 2. Okay, number 6 is going to be a little bit different. We have xy plus 8x plus 5y plus 40. If you look at this one, we have 2 variables, but we're going to treat it the same way, just like they were numbers. All right, we don't have a GCF across the whole thing, so we're just going to split it in half. All right, so if you look at the first half, what do they have in common? An x. And what's left over? Y plus 8. All right, on the second half, 5 and 40, we can pull out a positive 5. And we have y. 40 divided by 5 is 8. Again, those quantities match. So that's our common factor. So y plus 8. And then we can bring down x plus 5. Okay, number 7. We have AB plus 4A plus 3B plus 12. We're going to do the same thing that we did in number 6. So take a second, pause the video, try this one on your own, and see what you can do. Okay, let's check your answers. We don't have a GCF in everything, so we can split it in the middle. What does the first side have in common? An A. If you take out the A, what's left? B plus 4. We have 3 and 12. The GCF is 3. So we're left with B plus 12 divided by 3 is 4. Our new common factor is B plus 4. And we're left with A plus 3. Okay. And we have one more example. That's number 8. And it's 2x cubed plus 3x squared plus 4x plus 8. So looking at this problem, we don't have a GCF. We have a term without an x. And then I kind of want to say 2 is a GCF, but can 2 go into 3 evenly? No. So we're just going to go straight to splitting it down the middle. All right, in the first half, we can plot an x squared, and we're left with 2x plus 3. On the other side, the GCF is 2, and we're left with 2x plus 4. Now, what do we notice here? Do our things in parentheses match? Do we have a common factor here? No, we don't. So that means that this is not factorable. Okay? Or sometimes Math Excel will refer to these as prime. So I think in this assignment it says non-factorable, but those mean the same thing. So it's either not factorable or prime. So if you run into a problem like this in Math Excel, it's okay if those don't match and you double check it. If it doesn't work, it's just non-factorable. Okay? Now, like I said before, use these examples, try them on your own, use these to do your Math Excel assignment. And if you need help or have questions, want me to do more examples or whatever, just hop back in the Google Meet, or if it's after class time, send me an email or hit that Ask My Instructor button. Have a great rest of the day.